Now again, I'll show you by doing, so we're going to draw more lines here. If you want to follow along, just click line, click anywhere in your drawing for at the moment, it doesn't really matter. And what we'll do is we're just going to do it by eye. We're just going to go horizontal, okay, so it's 180 degrees, which means we're there. And I'm going to just do some random geometry. You don't have to draw exactly the same as mine. I'm just going to purposely do some weird lines, okay, maybe like that. And let's see what we've got. So if we click this line, we've got a horizontal constraint here. This line we don't have anything, but supposing we wanted that vertical, we can click vertical constraint. This one, we could make that horizontal, and that will give us a right angle here. We could also do this perpendicular constraint. So that will make two lines right angles to each other. Okay. So if I click perpendicular, I can select two lines and they're right angles. In this case, we could have just done horizontal, but maybe here we wanted this to be a right angle, but keep this line at that angle there. Okay, so by choosing perpendicular, selecting this line and then that one. Okay. I'll show you this. Okay, Inventor, again, it tries to guess what it thinks you want to do. So it's making them perpendicular, but it's moved the wrong line. We wanted to keep that at the angle. It's guessing that we wanted it to be horizontal and vertical. Okay. But what we can do, if we undo that, the reason it's done that is because this line isn't fixed. Now this is the important thing when it comes to sketching in Inventor. You want to, where possible, make sure that all your lines and all your sketch elements are fixed in place. Okay, I can't stress how important that is. If I needed a shape, again another pretty random shape, and I see if you snap to the end of a line it goes green, so that's closed now. So I could extrude that shape, but it's not fixed in any way. We haven't told it any of these lengths, we haven't told Inventor any of these angles or anything. If you then use that part in a complex assembly, and then later on you start changing some items and angles, Inventor will look around at the model and it will think, well, he wants to change the size of this line or this angle, but lots of things are fixed. I need to find something that isn't fixed, some geometry I can move, something where I haven't been told an angle or a length. And it will find something like this in your drawing and it will just destroy this shape in order to make something else work. It will do that because you haven't actually specified anything. This, as far as Inventor's concerned, this shape is just, it could be anything, and it's there to be moved about to make other things fit. So it's important that when you draw, you want to fix everything in place. Okay, so if we did want this shape, well, that line is fixed horizontally. Okay, we would also put a dimension on. Let's make that 15 there. So that line now isn't going anywhere. It's horizontal and it's got a dimension. This line is fixed vertically and it's also fixed to be perpendicular. Let's make that 20. Okay, this line is fixed to be perpendicular, so because that is fixed vertical, this is fixed horizontal. It just needs a dimension. 17. Now this line isn't fixed at all. We tried to make these perpendicular, but it guessed the wrong way. So what we need to do is click on dimension and give it an angle, and I'm going to make that 110. Okay, now with let's Now, when we go perpendicular, it's done the right thing because it couldn't do anything else. We've fixed this angle, so it has to move that angle there. Okay. And then we can actually, let's make that, gonna make that 25. Okay. So again, everything is being fixed now. So this line is perpendicular. It's also put a parallel constraint on. So it's made this line parallel with that line. I don't actually remember asking it to do that. What probably has happened is when we sketch, if you look, you can see these dotted lines come up everywhere. Well, that's Inventor, again, trying to guess. Well, I think he wants a line lined up with this corner. No, he wants it lined up with the center of that line. No, he wants it. So you can see it's always trying to guess what it wants you to do. So what it's probably done is it's guessed. You can see constraints coming up as I draw. I think that's perpendicular, and it's doing that. So then it's, as I've drawn, I think it's made this parallel, which is fine. Let's make that perpendicular. Okay. Let's put a dimension on there, and we're going to make that 110 again. There we go. So you can see, just putting some random dimensions on. There. So this now is what they call fully constrained. These lines are not going to be moved by the software because we've told it specific lengths and angles and constraints. And you might have noticed what I tried to do is put a 90-degree dimension angle there. Inventor will come up with this message. This message will be so familiar to you. It's not a bad message. It's actually trying to save you work. It's saying adding this dimension will over-constrain the sketch. What does that mean? It basically means you've already dimensioned this. You're trying to dimension something and you've already told Inventor what it is. And that kind of makes sense because you've told it that these two lines are parallel, and you've told it that this angle here is a right angle, is perpendicular. So this must be 90 degrees. Okay, it couldn't be anything else to keep these constraints you've already specified. So this is all fully constrained now, and you could go around, you could give more information here. Okay, but constraining, you can hopefully see that constraining something can be easier than dimensioning, because it might be you don't know what angle two lines are. Okay, it might be that you just want to draw something. You just want these two lines parallel, in which case you can click on parallel constraint. Doesn't necessarily mean they need to be a specific angle, but they just want to be parallel. You can use a parallel constraint to do that. So now hopefully you understand constraints a bit. It will still be a bit vague, I understand. Another thing that just you get used to by using it, but I'm going to go through them one by one. So, coincident constraint. So coincident just means it is on an object. Okay, if I did a line from there, okay, well actually this line was supposed to start. It was supposed to start on that line. I misclicked, or I didn't zoom in enough, something. I did it by eye, but it was actually supposed to start on there. Well, that's fine. Coincident constraint. First point, you click on the end of the line because you need to tell it which end of the line is on there. So you can see when you go over the end, you get the green point. So that point needs to be on that line and there. So now it's coincident. Still could be any angle, but it is going to finish. Then those two lines are going to touch, okay? The next one is collinear. Well, supposing we had a line there, and then I wanted another line to be lined up. You can see we get this dashed line, so that makes it easier. But what if those lines were drawn and, well, they're not actually in line with each other. I want to move this to be in line with this line here. So you can just click collinear. But if we were to dimension one of them, say from that point there, if we were to now change this to, let's say, 55, if we watch this line here, you'll see they both move because they are collinear. But we have fixed these with a collinear constraint. Unless we delete this constraint, these lines are always going to be in line with each other. Whether we change this one with a dimension, or whether we dimension this one, they would move together, okay? Concentric constraint. Concentric's a word, you'll see in Inventor. It basically means if something, it's used with circles. So the concentric point is the center. Maybe you have another circle here. You think, whoops. The smaller circle should lie in the middle of the big circle. Okay, so there. We click them both. They're now concentric. The center points are in the same place, basically. Lock. This refers to a coordinate system. A bit more complicated. Let's just leave that one for now. Parallel we've looked at, making two lines parallel to each other. Perpendicular, we've looked at horizontal and vertical. Tangent or tangential, I always struggle with that word. Tangential. If you have a line that is tangent to a circle, it means it comes off at the correct angle. Okay, so I'm going to try and do this. Say I tried to do this by eye. You see the line doesn't flow onto the, if this was, say, the end of a curved part, it wouldn't look right because that line isn't tangent to the circle. It runs in and then it kind of sweeps to the left before sweeping right. If we make it tangent, then you can see it meets the circle at the correct tangent so that it sweeps around nicely. Okay, that is one that we use quite a lot when we're drawing these parts, especially parts with curved ends, because you do want it to be tangential or you can run into all sorts of problems. So there's smooth, there's, again we'll do smooth when we've done some more splines and arcs, but symmetric. Okay, so we have this kind of shape here. Again, we've drawn it by eye, and we want these two lines to be the same angle from there. So we could say, okay, it's 30 degrees and it's 30 degrees, okay? And then we would have to say, oops, that's moved our center line, so we actually want that to be vertical there, and that's give us a geometry we want, but it's quite a long-winded way of doing it. Just delete that. So what we could have done is just clicked on this here, and you select the lines you want to be symmetrical, and then you select the mirror line if you like, and there we go. Now in this case it's moved the wrong one, but just by putting one dimension on we can change both of them because we have constrained these to be symmetrical. Okay, and equal, I think we looked at that before, but it makes lines equal length. So these now become equal that. And you can also apply the equal constraint to circles. So both these circles could be equal diameter. Now when it comes to which one it chooses as the main, as a priority size, you do want to set one with a dimension. Going back to what I said about everything being set, you do want to set one. So if we set that one 25, the other one changes. And you could use this to do a whole range of circles. If you wanted 50 circles to be the same diameter, you could just put equal constraints on them all and then put a single dimension on one object. That way, if in the future someone says it needs changing, you just change that one dimension on the one object, and because they're all constrained to be equal, they all change. And that's what these constraints are about, really. Saving you from putting in loads of dimensions. Quite complex sketches can be tied together in quite clever ways with constraints so that it's easy to change later on. And it also stops Inventor, as I said, automatically changing things to try and fit something else further down the line. Okay. So that's a quick look at constraints.